Okay, so welcome everyone. Thank you for joining. My name is Peter Eckler. I am Head of Future Technology at Zenitech, and this is our Future Technology mini series, episode 3. Today we will talk about the future of cloud or future cloud. Depends. It's a very interesting topic because cloud is used for so many things, and actually it's even hard to tell what the definition of the cloud is nowadays. How is it related to on-premise systems? Because some of the tools that were developed in the cloud, they are actually used in on-premise systems as well. So these are the things that we will talk about today, and I will try to bring you some interesting facts and ideas where and how this technology will evolve. Basically, or at Zenitech, our job is at the Future Technology Division is to bring the technology closer to our partners, to our customers. Our mission is to show which technology can help you to create better businesses, better opportunities, how the technology can help you to enter into the market in a faster or smarter way. And that's the reason why we are continuously researching the technologies. We are creating demos. We are bringing these new ideas and possibilities to the partners, and we demonstrate them, which are the stable one, which can save you cost, which can increase your revenue in different situations. So I hope that this mini-series also helps you in this perspective. I think we can jump into the topic. This time I brought you a quick agenda, what to expect, what will happen today. First of all, in the beginning, we will talk a little bit about the cloud technologies. What's the difference between cloud and on-premise systems, when to use on-premise, when to use cloud, because both of them has benefits. And we will also talk about generally in terms and definitions about these technologies, because a lot of things have been invented and introduced in the couple of years. Then we will have a small Q&A section in the middle, because it's an interesting topic, and I'm open for discussion. So please bring questions for this Q&A session as well. We will have 2 interactive quizzes as well. And after the first Q&A section, we will talk about future cloud service technologies. What are the latest trends? And I have tried to find some interesting technologies that probably you haven't heard about or not as much details. And at the end, I will show you some use cases for what kind of applications can be accelerated with these technologies. So let's jump into the future of cloud. First of all, it's very interesting to talk about this technology, because it's hard to tell when and how should we use cloud, and when the on-premise is better when you manage your own servers, because both of them has advantages and disadvantages. I will jump to this point right now after this slide. Then we will also talk about that, what is cloud computing, where can we utilize them, actually what are these different definitions, like serverless computing, edge computing, what does it mean from the cloud point of view. And we will also talk about that, how to take the full advantages of cloud technologies and environments. Then definitely we will cover the major service providers nowadays, AWS, Azure, and Google Cloud as well. We will talk about the issues of vendor locking and the possibilities to avoid it. And we will also discuss the question of how we can go faster to the market when we apply proper cloud or on-premise strategies. And we'll point out to some emerging technologies that actually can bring some spice in the cloud technologies nowadays. Before I go into too deep, just I want to plant this idea for everyone that probably you might think that the cloud is a little bit boring. Many people are talking about cloud in the past 15 or 10 years. Why do we talk about these things? My answer is that actually all the latest technologies like blockchain or AI or modern services that serves millions or even billions of users, they are available because because the cloud technology is with us. So actually, it only works These new technologies only work when there is a proper cloud provider in the background, which is able to manage huge amount of data. That's why this topic is very important, because actually it's the base of every modern solution nowadays. Another interesting thing is that we should talk about the general advantages of the cloud, but we should always compare it with the on-premise systems, because sometimes the benefits are not the same, and sometimes you have to consider whether to keep the cloud system or whether to go back to the on-premise systems. It really depends on the different use cases. First of all, in general, we can say that cloud can help with cost saving, and I say it can help. It might help. But if you just buy services without any control, or if you don't optimize the system, that at the end it can be actually more expensive than the on-premise systems. But if you use it properly with the right technologies and the right optimizations, then it can save costs. Another thing is that it definitely increases the efficiency, because you have a lot of processing power in the background. I think nobody argues with this one. Another good thing is that it increases the agility. You can much faster respond to changes. You can much faster increase the processing power in the background with the cloud technology. And it provides very good out-of-the-box security systems to protect your data. Obviously, if it's a very sensitive data, and for some reason, if you are not allowed to put it in the cloud, then this doesn't help. But in general, it can be really, really useful if you use the proper services. Then what does cloud provide for companies? Actually, why should a company consider to use cloud technologies? It's definitely used for business development. If our company has just a local solution, and it can be used only locally in the country and so on, because it is not scalable and so on, then it's not really it doesn't allow us to evolve our system. If you want to go to globally, and if you want to have users from all over the world, then cloud is definitely a good way to introduce your web system for everyone. Another thing is that it gives you a very good storage for different data like databases, images, and all these kind of things. And it has very great and well-designed tools for analyzing and processing the data, analytics, monitor the system, and all these kind of things. But what we will mostly talk about is the bottom line is that how can it help to create new products and services in a cost-efficient way? And again, let me just give you an example. For example, if you think about that, I would like to implement the next facial recognition solution because I have a great algorithm that can fully tell on my face whether I am happy, sad in different levels, and I can use it for advertisement or for any kind of extra benefits in the retail sector, for example. And if I have such an algorithm, if you want to develop it by hand and run it by hand, you have to really spend a lot of time with the infrastructure and with implementing the algorithms in every low-level way. But if you use the proper cloud services, you can reach the market much faster, maybe even 10 times faster, and you can validate your idea, whether it's really useful for other companies, whether you can really monetize your idea. The cloud can help you with this one, accelerate bringing the business in life, basically in many situations. And before I continue, I would like to ask your opinion about one question about what actually do you think is the biggest advantage of the cloud? If you're online, you can see now a quiz that asks that what do you think, what is the biggest advantage of the cloud? There is no wrong answer. I'm just curious about the overall result. I have listed there cost saving, flexibility, scalability, availability, security. Please tell me your opinion, and at the end we can talk about it. Okay, let's just wait for a few more seconds until you answer who you are online. And I don't exactly know if everyone has responded. Please select one of the answers and then we can see the results. Okay, let's close it and let's see the results. So you can also see it if you're online, but basically scalability was selected by most of the people, but cost saving, availability is also there. It's interesting that not many has selected the cost saving, and actually it's kind of I totally understand, because nowadays there are a lot of papers and analysis about how expensive is actually the cost, and I agree. Especially when some system is used, for example, without optimization, or if the solution itself is not actually generating enough revenue, then the cost of the cloud can be actually very expensive. So let's just talk a little bit about the definition of the cloud, because there is an official definition, what you can see here. Many people are asking that, is it basically just a buzzword? It's a bunch of servers. Why do we need a definition for that? And actually, the official definition is that it's a network of remote server hosted in the internet and used to store, manage, and process some data. But to be honest, I like the second definition much more, which tells that the cloud is the on-demand availability of computer system resources, especially data storage computing power, without direct active management by the user. And I like this on-demand word, which means that it uses more resources only when needed. So it really tries to optimize the usage of the resources, which is good for energy consumption point of view and from many other reasons. That's why I think that that's a great definition for the cloud, that it's a on-demand availability of resources in the network. Why do we actually need to talk about the cloud? What is the issue with the traditional systems? We have servers, we can plug in more servers in the system, but the problem is that when you do these things manually at your company, you need to hire a lot of IT people for maintenance. You need to install the operating system updates manually. You need to deal with malwares. You need to deal with external attacks if somebody tries to jump into your system. You need to deal with the manual updates of softwares and many other things, create good firewalls and a lot of things. And actually, it causes a lot of problems for many companies. And maybe if you are not even sure that your solution will generate enough revenue, it's a waste of money to buy a lot of servers without testing the idea, how the market will react to your idea, your software that you have developed. So there are actually issues with traditional systems, and cloud can be very useful in these situations. The key functions is that it's kind of a self-service and on demand. You can configure it remotely without touching the physical devices, how it will operate, how users can access the systems, the networks, and everything can be actually configured remotely. It's very flexible, it scales very well, but you need to configure it properly to do such things. But still, only one person can do all of these things on an administrative side, or one or more, a few more people. But definitely, you don't need all the time go to the server room, clean the servers, and do the maintenance manually, which is a lot of extra time for everyone. Another interesting definition that we have to understand is the deployment models. What is actually the cloud? When we deploy a system, where can we deploy a system? What type of clouds do exist? Maybe that's the right question. There is the private cloud, which is actually very good. It's kind of belongs a little bit to the on-premise category, where the machines owned and operated by one organization. It has much enhanced security, and we can be sure that our data is not stored in random places of the world. So in that case, the private cloud is a good approach. I will talk about it a little bit more details, all of these categories. The public cloud is where the services are owned and operated by a third-party vendor. It saves us a lot of time. We can use a lot of pre-prepared services and solutions, but in this case, we lose the privacy a little bit. And there is the hybrid cloud solution. Personally, I like this one very much, which is really allowing us to put some of the sensitive things in a private environment and put the general things like the general AI algorithms that needs a lot of processing power or load balancing or something in a public environment. And in that case, this is what we call hybrid cloud, basically. You might meet with this definition edge cloud, which is it's a little bit different, but it's good to mention. It's the distributed network of cloud computing resources located at near the edge of the network, especially when we are talking about the 5G network. The 5G cell towers can be considered as edge cloud nodes because they can do a lot of processing locally, or a smart home environment can be considered as an edge cloud. We have a smart home hub or control system at home, which is managing a lot of sensors and different devices what we have at home. But it only communicates with these small sensors locally at the edge of the cloud. But the control system is connected to the cloud because I have to be able to control the smart home from different parts of the world. So it's actually connected to the internet, to the cloud, but it manages a lot of local things at the edge of the cloud. And there are other type of clouds when, for example, a huge organization like a government creates a local cloud server farm, or a big university creates a local server farm for researches. This is what we call the other type of clouds. The private cloud is used in those situations when you really need to protect your data and you need to control your data. So if you think about a solution where it's really data sensitive but need to be scalable, then the private cloud is a good idea. It better controls the multi-tenant environments. All the configuration is under the organization's control, but it still uses such a software front ends and admin interfaces that are familiar to everyone who is working with the cloud, but the resources are actually managed privately. So that's one big advantage. The disadvantages is that it requires some skills to operate it, and it introduces additional local costs because we need to deal with the private devices at our site. The public cloud is the general cloud what we usually talk about when we use AWS or when we use Azure or when we use Google Cloud. These are the public cloud, biggest public cloud vendors. They take a lot of work from us because there are pre-prepared systems, there are on-demand available resources. We just need to configure what do we need. And it helps a lot of in a lot of things when we create a new software. It, of course, also has disadvantages because we really depend on the provider. So what happens if the AWS server farm is down on some part of the world, then actually our system is not working anymore. Or if we want to transfer from one vendor to another vendor, like if we want to move from X to Y. I don't want to mention the names because you might think that I have some advantages, or I like one of the cloud providers more than the others. But if you want to move from one cloud provider to another one, it's actually very difficult if you use a lot of services. If you have just simple virtual machines, then it's fine. But in that case, you don't really use the services of the cloud. So the control is a little bit different in that case because the vendor is giving the most of the controls and the data is not stored locally, so I have much less control over my data as well. The hybrid cloud, what I mentioned, it's actually a good solution in many cases. When we have some data, we want to use, we have some sensitive data, so we can use the advantages of the private cloud, but we actually want to be very scalable. We want to use a lot of services that are available only in the public cloud, like a smart AI, object recognition provided by AWS or Azure. In that case, we can create a hybrid solution. The sensitive part is in the private area, the others are in the public area, and that's a good thing. It also still has disadvantages, like the vendor lock-in is also here. So you still choose one of the vendors, and if you need to move to another one, and if you use a lot of services from that one vendor, there isn't actually straightforward migrations from one cloud provider to another one. So it still has disadvantages, and also the complexity increases if you use a hybrid system, because then you need to do the maintenance for the private and the public part as well. That's one thing about the about how to deploy the cloud and where to deploy the cloud. In every situation, you need to analyze it carefully and select the best options for your needs. It usually works to consult with someone who has experience with this. We typically do this with our partners, and we have to find the best, the efficient, the cost saving, from cost saving point of view, the best solutions, and from long-term usage point of view, because we believe that when a software is created, it has to be created in a way that it can be maintained for a long time, because the selected technologies are stable. Another thing that we should talk about is the level of services. How can we, what kind of services do we have in the cloud, and which level are we using the services basically? Here you can see some familiar words. Probably many of you have met with these infrastructure as a service, platform as a service, and so on and so on. Let's just dig into the deep a little bit and talk about the interesting parts. So many people like the infrastructure as a service because it actually just gives you the infrastructure, the machines, the disks, the network, and other resources, and we can decide what type of operating system do we install, what kind of container technology do we use, and we can run our own favorite .NET, Java, or Node.js, or other type of services in these machines. It has a lot of benefits. It can be very performant, but it has a lot of drawbacks or cons as well, because it can be you need to do everything manually. Basically, this is what I'm trying to say, and we just use the machines. We don't really use the advanced capabilities of the cloud. So it's useful in some situations, but maybe it's worth to consider to use some of the existing services and not implement everything by yourself on the infrastructure level. Most of the providers gives us this level of services like Azure, AWS, and so on. We can hire virtual machines. We can install whatever we want on those machines, and they will work. So this level is available on most of the cloud vendors. And they obviously support virtualization and container technologies. So still we can very well design our system. We can use a microservice architecture, and we can create an easy to install software solution in an infrastructure as a service environment. And it's really used in many systems when you need full customizable environments that you want to manage by yourself. And yes, because container technology is all supported on these environments, you can use all the advantages. In this talk, I don't want to go into the details of virtual machines versus containers, but containers nowadays are really efficient for specific tasks. You can optimize them well. And with Kubernetes or other orchestration systems, you can really well design your system in a very scalable way. The next level of service is the platform as a service. It's almost like infrastructure as a service, but actually we don't need to care about installing the operating system, installing the patches and updates. There is no need for such things, no need for security patches and those things. They are managed by this platform as a service solution. We just actually select what kind of environments do we need. Like I need a Java environment, I need this and that database technologies, and the platform will install these things to us, and we can concentrate much more to the business logic. So we will not spend too much time with the infrastructure design on the virtual level and in the cloud, inside the cloud. We can just focus much more on the business logic of our application, because the platform with the operating system and the required environments like the Java virtual machine is available, and this is kept updated for us. This is why we are paying for such services, because somebody else is automatically keeps the platform updated for us, and we don't need to care about the platform level of updates and security patches. Again, most of the cloud providers support this platform as a service level of working. AWS, Google, and all these kind of things, they allow us to get a platform, like get a DynamoDB instance, or get another instance of different databases, or implement or get an Elastic Beanstalk instance. We can just use them. Or Heroku is also a popular platform as a service provider. And when we configure it, we say that we need Java, we need a database, then we will have an environment where it's already pre-installed with the latest security patches, and we can just focus on our application and the business logic. The next level is the backend as a system, backend as a service, backend as a service. I would say that I also like this pretty much because let me say it again with some different ways than the official definition. In case of backend as a service, as a software developer, as a mobile application developer, you can develop the whole system without backend knowledge. So basically, you don't need to be a backend developer. You don't need to understand REST APIs and backend certificates and secure communication as all these things, because this backend gives you as a service and you can just configure it. And as a mobile or front-end developer, you can just write such a code that please save this object in the database, and it will automatically create the database, create the table for you, and save the entity in the cloud, and other mobile applications can immediately access those data. So without the knowledge of the backend, you can just use backends for your system. Like, for example, if you have a great idea, you want to create the next level of car sharing applications because you have some cool ideas there. In that case, you don't need to hire backend developers. If you just want to test your idea, you can immediately start with the web or mobile application, and the backend will be provided to you as a service. You just tell on the front end side what you want to save, what you want to use from the backend, and it will be available for you. And nowadays, the backend as a service technologies gives you a lot of technological advancements. So it has many advantages. You can really quickly go to the market. It gives you a lot of managed services. But again, the vendor locking is an issue here, because what if you select one of the backend as a service technology, like, for example, Firebase or Backendless, and if they decide to bring down this service, then it's very hard to move your application to another backend as a service provider, because you have used a lot of existing services from there, and maybe it doesn't exist on another backend as a service provider. So it has some negative things as well. You really need to consider in the right situation that which level of service you would choose for your system. But as I mentioned, nowadays backend as a services are very popular. One of the most popular one is Firebase. It gives you many features, gives you authentication, gives you machine learning features that you can use out of the box in your application, gives you real-time analytics, performance monitoring, push notification services. So many things is available, and you don't need to be a backend developer to use these things. From the mobile or web front-end side, you can immediately use these technologies. In this small example that you can see on the screen, it's basically a chat application, but I'm using it at the university to teach the Firebase to the students. And I just want to quickly show you that basically backend as a services gives you a database in the cloud, push notification, as all these things. And it gives you this real-time functionality as well, that when you do something on the mobile, and as soon or immediately when you upload it to the cloud database, it can be available immediately to the other users because of this real-time functionality. And because backend as a services typically run in a cloud, there is no issues with scalability, and then such things can be done. And just to make this presentation a little bit practical, if you are not aware, or if you have never used the backend as a service before, actually I want to show you one small thing, how, just for a second, how an admin site looks like for such a backend as a service. So as a mobile developer, again, you don't need to write backend code. You just get this nice administration front end, and here you can manage your databases in live. Here you can see that there is one message in the database. These are the arguments in this document. These are the parameters. These are the fields. These are the collections. You can see who are the registered users. You can get a real-time analytics that when and how people are using your application, where are the crashes. You can use different machine learning features, and it's available out of the box. And as long as you develop, you don't need to pay for it. And the cost is actually automatically increases when you have more and more users. But Actually, if you have more and more users, if you have thousands or millions of users, then it will generate some revenue. So you will be able to pay for this backend as a service. The next level is the software as a service that allows you to use out-of-the-box softwares. Probably this is a bit more boring part because we all know what they are: Office or Dropbox in the cloud or Google Drive in the cloud and these kind of things. So we typically use these software as a services. The biggest advantage is that it depends on the internet connection. So I cannot access my online stuff if I am not online. That's something that you have to consider. However, what I would like to highlight here is that if you are a developer or a company who is developing softwares, software as a service is a great way to offer your product to your customers. So we don't give installation files. We just say that we are managing the software for you. It's available on this link. We are running it in the cloud, and you pay as you use the software, and everything is managed as a service. So that's a great way of promoting products. The big companies like the streaming companies, the file sharing companies, or the music sharing companies, they are using similar things. It's also a software as a service solution. Okay, we have talked about many interesting things. I recommend to stop now for a moment, and let's have a Q&A section. What do you think about what you have heard so far? I have highlighted some topics here that we can talk about, and I'm open for your questions. I see that some people has joined to the webinar. Do you might have any questions? You can use the Zoom chat, or the Zoom also has a Q&A feature. Feel free to ask about these topics if you have anything to add, or if you don't agree with something, or if you have any questions. I'm waiting for a few seconds, half minute. I already see one question. While you are writing maybe others, I will try to answer it. The question is that, when would I recommend using cloud instead of on-premise? It's a challenging question. I expected something like that. It really depends on the current situation and the use case or the application itself. So, for example, if you don't have sensitive data, you don't have any regulation like GDPR or some really private things or healthcare stuff, then I would recommend to try the cloud first, but definitely consult with someone who has done it before and help you optimizing, selecting the best services and optimizing the costs. Because you can reach the market much faster, so you can provide the solution much faster available for everyone globally if you use the cloud. But if you have a sensitive data set, or if the application is designed just for a small amount of people, like it's an application inside for a company and it doesn't need to support multiple sites, then the on-premise is also a good idea, because in that case probably there isn't any sense, doesn't make sense to use the cloud globally if only 100 people are using the solution or something like that. So yeah, it has to be checked carefully in every situation. Are there any other questions maybe? If no, then let's continue. And at the end of the session, you will also have another Q&A section. So feel free to ask if there are anything. I'm really happy for the questions. So don't hesitate to ask if you have anything. Meanwhile, you can also write in the chat, because we will read those questions at the end of the presentation. The next topic, it will be smaller and I will be faster, don't worry. It's about modern cloud native things. What is actually this cloud native? Why do we have this definition? And what kind of things belong to this category? Cloud native is a cloud-based approach of application development, basically. It encourages to use scalable, available, and elastic technologies, embraces you to use these principles in software development, enables developers to build applications that can take advantage of the cloud native features like the automatic scaling and so on. And it also supports the process of development as well. Like you can do the continuous integration, you can do the code analysis and the testing in the cloud environment as well in a dynamic way. And it allows you quick and easy deployment. So when your software is ready, when a new version is ready, then you can very easily release it and deploy it and make it available for everyone. I don't know if you are aware of that, but for example, these big companies like Spotify or something like that, they actually make updates in their system weekly because it's so well automated. If something is fixed, then it's immediately deployed in the cloud because so many good automation tools are designed with this cloud native technology. It can also use for development processes, helps you to increase the efficiency. In this DevOps terminology can be really used in the cloud native environments. It can use all the benefits of the cloud providers, the containerization technologies and so on. And the whole deployment of the software can be much faster and can be automated in a very well designed way. And it's really important to automate our processes, because when you do automation, you save time and you save cost. You save time for developers. You can give the new services much faster to your customers, and you can focus on other features of the application instead of wasting time with the deployment and all these kind of things. So automation is always a good idea, and cloud can help us really well there. Cloud natives helps us with microservice design, with container-based solutions, with automation and all these things that I have actually mentioned before. Let's just talk now a little bit about the interesting, spicy services that we can also use in the cloud, like provided by the different cloud providers. I know these letters and this figure is very small. It just tries to give you a feeling how many services are out there. But actually, what I will do now is that I have handpicked two services from each providers, and I want to show you that maybe we haven't even thought about that such things exist in the cloud out of the box. And when you read these things, you should also consider that why is it good or why is it worth to consider using such services? And the answer is that because you can go to the market again much faster. If you want to implement any of these services by yourself, it will take you months or even a year to develop such things. But in this case, it's out of the box available, and you can test your business logic and the application itself in the cloud. That's one reason. AWS Amplify is actually a backend as a service. It's very similar to Firebase, but it's provided by AWS. And the big advantage is that it's connected to other AWS services very easily, like AWS Cognito for authentication, or the AWS Pinpoint if you want to use push notifications, or AWS CloudFront if you want to have a lot of caching and content delivery in your application, if it's a content-heavy type of application. So it's very well connected to other services. And it gives you a nice tool set for creating mobile and web applications. It even gives you UI libraries and components to design your application and implement it much faster. So it's a good way for creating mobile and web applications using the power of the AWS. Another funny thing, it was recommended by our CTO to mention it. It's the AWS SIM Saver. The AWS SIM Saver is a very exotic feature, but actually it's very powerful if you need a similar thing. It's a simulation for big cities and landscapes and that kind of things. It gives you a three-dimensional visualization. It allows you to create simulations with a huge amount of objects and sources and data stuff. It is integrated again to other AWS services from where you can grab the data. There are ready-to-make simulations. It's easy to share simulations with others and scale the simulations. So let me give you an idea. Like if you want to introduce a new location-based advertisement system in a huge cities, how is it, how will it work in big environments in the city landscape, then it's a good environment to test your idea and simulate the idea. Or if you implement a propagation algorithm, that if this information is available in this part of the city, how fast can it propagate to other parts of the city? These kind of things can be checked there. And again, I don't want to go into the details with all the AWS services. I just want to show you this number that actually when I last checked, there are more than 200 services in the AWS. So you can imagine that we can do a lot of things out of the box there if we know how to use these technologies and how they are connected. From the other cloud provider, Azure, let's see some cool stuff here as well. Azure also has a very good AI service system. It gives you out of the box form recognition, cognitive search, metrics advisory, video indexing, reader solutions for compliant text, and it also gives you a nice chatbot technology, what I will talk about now. And as we all know, Microsoft has acquired the OpenAI technology, so probably more services are coming into Azure as well from this point of view. Another thing, a little bit more concrete, the Azure bots. I find it very interesting because chatbots are becoming more and more interesting nowadays. And this gives us a customizable chatbots with natural language processing, with adaptive machine learning, monitoring, and many, many things are available through that. If you want to implement your own chatbot in your service, you don't need to start from the scratch. It's available here. Last, Google Cloud, obviously, they also give us a lot of features, like you can create documents processing with AI, object character recognition, or visual recognition. You can use recommendations, algorithms provided by Google. You can create solutions which are integrated in the Google Assistant with the dialog flow. So it also gives us a lot of cool features, which we are not able to do them by ourselves, or actually not in a time efficient way. So to sum up, I would say that it's worth to use these services from many perspectives. But the biggest thing, that my personal opinion, is that it's really good for time saving, because time is a very precious resource. We cannot buy time, even if we have a huge amount of money. So every technology and everything that can help us to save time is actually worth to investigate. And lastly, let me just show you some interesting use cases for the cloud. These are a little bit personal opinions that I want to show you when a cloud can be used for us. For example, if you think about software development, is very expensive. But when you create a software, it is said that you need to create reusable components, you need to create reusable codes, because in that way it's easier to test the code. It's easier to, the whole architecture will be cleaner if you think about reusable components. And what I would like to add to this one is that if we create reusable components, why do we create reusable software features that can be sold to others who need actually same functionalities? So, for example, why do we develop all the time web shops for every partners? The better idea is to create a web shop engine, and that can be customized by other things. Shopify is doing similar things. Or if in other sectors, if you need a logistics software, why do we develop it always in small times? Why don't we create it in a configurable way? And in that way, all of our great things can be reused by others as well. So it's good to think about how to create reusable features. And that was our idea. We have participated in a hackathon with this solution, what you see here. It's actually a web shop plus package delivery solution and real-time monitoring where your package is traveling and when you will get that package, and it will give you even a virtual doorbell. And in this hackathon, we have implemented the whole system basically. And the big idea is that, for example, if there is a local company who has a nice shop locally in the town, but is not a digital company, they can just go to us. And because we are using cloud technologies, it supports multi-tenancy. So within 5 minutes, we can give a customized web shop to that local store or local shop, and immediately that local store will be online from that moment, and it will have all the nice features: online web shop, package delivery system, and real-time monitoring and all these kind of things, because we have designed the system in a way that it's really reusable and supports multi-tenancy. Another demo, what we, actually it's not a demo, it's a product what we are developing continuously. It's called Sensor Hub. It's for smart manufacturing. Nowadays, the manufacturing industry is becoming more and more modern and digital. And actually, in every big manufacturing house, you do kind of similar things. You have displays to show the current status. You have some local sensors. You measure the performance of the factory. And we have created many services. It's a really customizable solution. And if somebody wants to have a modern Industry 4.0 solution, then we can recommend our product, because we created in a way that it can be reused. And the last example, what is a good example for how to create reusable solutions is our Info Hub system, which is a content management system, a native mobile content management system. We have implemented so many mobile applications in the past, and we actually feel that what are the big features that are typically needed in a mobile application. And with this Info Hub, we wanted to give something to the community that actually, if you need a mobile application, then we have created most of the work for you. If you need a list of news, if you want to have a QR code based managing your customers who can go to somewhere, QR codes based content sharing, or if you want to access your users with push notifications, if you want to have location based content, all of these modules are pre-implemented. And if you go to the website, you can order your instance of Info Hub. You can customize the name and look and feel and all on. And the idea is that actually it can be used in different domains. It can be good for companies, for HR support, for sharing the information with your employees. It can be used in smart cities. If a city decides to give something to the people who live there, like a real-time information sharing about traffic jam or things like that, the Info Hub system can be used there. The last example for sport clubs, if a sport club wants to reach its audience with real-time information, with some sending the best events of the match in a video format from a football game, this Info Hub system can be used for that as well. And it's also good for media and live shows. If you have a TV channel, if you have a radio channel, the radio is a very good example because we are just listening for that. But with this application, we can give something visual to the radio listeners. They can do live voting through the application. And all of these things existing out of the box, within a few minutes, everyone can have its instance and can use it. And that's the way how you have to think about when you create a software, that actually you can create it in a reusable way and open it for a wider audience. And lastly, I would like to mention some ideas that can be used or can be considered as next generation cloud features. First of all, I think everyone agrees that the AI is developing rapidly. So the AI-driven cloud services, like automatically does the automation, automatically discovers the analytics, that the cohesion and correlation in the analytics, like automatically discovers that you lose users because your website doesn't have a header part. So it can really give you recommendations. That's, I think, very a great feature that will be, or it's already there in the cloud. Another one is autonomous databases, which are handling themselves in a more autonomous way. I think the quantum computing will arrive to the cloud soon, and there are already signs that, because quantum computing can be very efficient, and that's a good thing. Cloud gaming, you don't need to buy hardwares locally. You can enjoy the full game experience through the cloud if the network is fast enough. I think this will also arrive soon. And virtual reality, augmented reality is also coming through the cloud. And the last thing is that because all of the clouds have APIs, which means that you can write code to launch an instance, to start a service, and so on. I think that sooner or later, the AI will build part of our cloud systems in a way. I just played a little bit with ChatGPT, and I asked it to create an architecture in AWS for a multi-tenant web shop, and you can see the result here. It has listed those AWS services that I should probably use, and actually it's not bad. Most of the things are needed if you really want to create a nice web shop in AWS. What if OpenAI will have access to the AWS SDK and it can actually create the things for us and write even the code for us? That's an interesting question. And now, before we conclude the presentation, I have another quiz. If you are online, and I'm happy that you are still online, please answer this question. Question is about that. What do you think? Which sector will use the cloud the most in the future? Financial, gaming, advertisement and marketing, retail, healthcare, education, media, or something else? I would be happy to see your opinion. It's an interesting question because we can say that basically everywhere can it be used, but I'm curious, what do you think, where it will be used most heavily? So if you could answer this one, I would be happy to hear or see your opinion. And I think we can close it and let's see what your answer were. Okay, and interesting, it's a more distributed. Retail and the media is the winner, and after that we have education, gaming, and financial services. I think it's very well shows that all of us think that cloud is used in different domains, not just in one or two domains. So it can be used in every area, basically. And the last thing that I would like to give to you is some kind of ideas. If you consider to go into digitalization, if you consider to develop a new service or upgrade your existing services, either in on-premise or in cloud, because what I showed you, those services, there are ways to run them in an on-premise environment or alternative open source solutions. Anyway, if you consider such things, you need to go through these steps, define first the goals, what you want to achieve, analyze your current digital capabilities, what kind of existing services need to be kept running, what can you move to the newer environment. You have to analyze the security and data requirements because it influences the decision what kind of service level and what kind of deployment environment should you choose. We have to determine and figure out which cloud provider do we choose, and you have to do real calculations about the costs and consult with someone who can help you with that and select the best services because it's a complex topic. So it's selecting and designing the new cloud environment or on-premise environment. It needs experience, so it's good to consult with someone and plan it properly. Planning is very important. Then the implementation of the infrastructure or the cloud environment comes. You need to consider to have a development, test, and production environment as well that can help in your processes. You need to consider the security and the backup and the restore strategy. So how the data should be backed up, how it can be restored if something goes wrong, or if you need some redundancy. Then monitoring is very important. It's not enough to say that I am in the cloud or I have designed a well scalable on-premise system. It's really not enough. You have to have a monitoring system that actually proves that your system is scalable, proves that the users get the responses very fast and everything works normally. It's essential stuff. And the last one is to be prepared for changes and adapt and evolve to changes, because the technology in the cloud is evolving so rapidly. New features are arriving. There are major upgrades in every services, and there are new requirements from the customers. Hopefully, when your customers, your partners will see what your software can do, they will ask for more features and upgrades and changes, and you have to be ready for that in the cloud level as well. And we are happy to help you with this journey. If you wish, feel free to contact us. And thank you very much for watching this section. And we have now time for Q&A. And let's see if you have any questions in this topic. If you have anything else to add, I'm happy to see your opinions and questions. Again, the Zoom chat or the Zoom Q&A section can be used here. And that was my last slide for this time. Anyone, any questions? If you are still here with us, I'm happy if you send questions. Meanwhile, I have already received one, but I would really like to hear the feedbacks from the others and so on. Let's just answer this question for now. What do I think that what will be the next generation of services that we will see in the cloud? Again, it's a very interesting question. It's not easy to answer because there are so many things out there. What I think and what I see is that different AI stuff is arriving in the cloud much faster than we expect. So we will see more artificial intelligence related solutions in the cloud, like automatically gives us recommendations or it will give tools to developers to automatically use blockchain in different technologies, or actually I think the image processing and the video processing with AI technologies will also arrive in the cloud. Like, let me just tell you an extreme example. Zoom meetings and a real-time Photoshop filter will run, and it will prettify my face while I am talking to you in real time. And even more, this kind of AI-driven media manipulations or media generations is arriving. So it's very interesting. How close are we to general AI? That's another question. Again, it's a nice question that we can discuss when we are drinking a beer, because there isn't a professional answer to this one. I think we are closer than we think, but it will not be there immediately. Probably you have seen many examples how this ChatGPT is making mistakes. It's very confident, but it says things which is not actually true. I think it's a bit hard to fix these things, so it will not learn these things much faster. But the way how we use the AI technologies, because it's open now, it is able to learn and collect data much faster. And the artificial intelligence is all about how much data it can use. Because of the cloud, we can store data. Because of the cloud, we can process the data much faster. And the AI can be intelligent if it has more and more data, because we people, we are also getting more and more intelligence. If we learn different things, if we learn tech things accurately, then we can be more intelligent. If we solve problems more and more, then we will be more intelligent. And it's true, even more true for AI. And nowadays, because we are using it, the data is being collected, solutions and problems are being learned, which are good, which are not ones. So I think we will have better general AIs much faster than we expect. I don't want to say that in 2 years, but I think in the next 10 years will be very exciting from this point of view. And thanks for this question. Do you might have any other questions? If no, then thank you very much for being with us. Thank you for listening, and thank you for your questions. If you have anything else, or if you want to contact us, you feel free to send us a message, and we are open to answer any other questions offline, asynchronous way, if you have any. Thank you very much, and wish you a pleasant day. Bye-bye.